In today's lesson, we're going to be taking a look at multiplying polynomials. So we've already talked to this point about multiplying monomials, so multiplying 2 or 3 monomials together. Today, we're going to talk about how we multiply polynomials that have multiple terms. So first out of our notes, we're going to take a look at multiplying just a monomial times a polynomial. So this is going to be something where we have one term being multiplied by either two terms, a binomial, or possibly even a term being multiplied by three terms. Remember that a polynomial is basically the sum or difference of more than one term. So in order to solve these problems, what we're going to do is we're going to use two things that we've talked about so far this year. We're going to use, first of all, the distributive property to distribute that monomial through to the polynomial. Then we're going to use the rules that we just learned about with multiplying monomials in order to simplify that. So in our first example, you can see we have negative 3x squared outside of parentheses. Inside of parentheses, we have the trinomial 7x squared minus x plus 4. So we're going to go ahead and start this off by distributing that negative 3x squared through to each of those three terms in the trinomial. Very similar to what we've done, the only difference is now we're distributing a monomial instead of just a number. So when we distribute, we're going to go ahead and write this out. You're going to have negative 3x squared times 7x squared, and then negative 3x squared times negative x, and then negative 3x squared times 4. When we write that out, it looks a little messy at first, but as we start getting a lot more comfortable with these different rules, we might be able to skip this step and be able to move into a more simplified answer a lot quicker. So see, we have three sets of monomials that we're going to need to multiply here. So the first set of monomials, we have negative 3x squared times 7x squared. Using our product rule, we're going to multiply our coefficients, negative 3 times 7 to get negative 21. With the variables, since we have the same base, we're going to go ahead and add the exponents. So we'd get x to the fourth power. In the next set of monomials, we have negative 3x squared times negative x. If we multiply the coefficients, negative 3 times negative 1, we need a positive 3. And then we have x squared times x, which when we add the exponents will give us x cubed. The last set of terms, negative 3x squared times 4, we're going to multiply those number portions. So we're going to get negative 12. And then we just have one variable with one exponent, so that nothing's going to change with that variable portion. It's just going to stay x squared. After we distribute, after we multiply, simplify that, we want to always look to see if we have any like terms we can combine. Since all of these monomials have different exponents, we can't combine them. Therefore, this is going to be our simplified answer to that product. Let's take a look at our next example. So next example, you can see we are getting a little bit more complicated here. Notice that we have two sets of parentheses, so two portions that we're going to need to distribute. So the first part, we're going to distribute 2p to negative 4p squared and 5p. Second part, we're going to distribute a negative 5 to 2p squared and to 20. So I'm going to write all of that out here as we multiply. So we have 2p times negative 4p squared. We have 2p times 5p. Then in the second set, we have negative 5 times 2p squared and negative 5 times 20. Just keep in mind that this is going to be a very common area of mistake. A lot of people, when they distribute that, are going to forget that negative and are going to end up with a different constant in the end there. Okay, once we go ahead and write that out, we now need to start multiplying these monomials to simplify. So the first set, 2p times negative 4p squared. Multiply your coefficients to get negative 8. Add the exponents on your variables to get p cubed. And we have 2p times 5p. Multiply our coefficients again to get 10. We have p times p. Adding your exponents would give you p squared. And we have negative 5 times 2p squared. So negative 5 times 2 is negative 10. P squared. We don't have any variables to combine with that, so it's going to stay the same. And then we have negative 5 times 20, which is negative 100. Again, once you multiply that through, you want to always make sure in the end, look for any like terms, see if there's anything you can combine. In this case, we actually do have like terms. We have two terms that have p squared in them. So we can go ahead and combine those like terms. Right here we have 10p squared minus 10p squared. As you might know, 10p squared minus 10p squared is going to be 0. That's going to cancel out. So basically all we'll be left with is negative 8p cubed minus 100. And again, those p squared terms are canceling out because if I were to actually if I were to actually subtract that, 10p squared minus 10p squared, you're going to get 0p squared, which is just 0. And we don't need to add or subtract that 0 because it will not affect the value of our expression. All right, let's take a look at the next one. So the next one, we're actually going to be dealing with an equation here. At this point, we're not going to deal much with equations because we haven't talked about how to solve equations that really involve exponents. We'll get into that in our next unit. So for this, we're just going to start by simplifying and kind of see where that takes us. So I see there's 2 places here that I can distribute. Let's go ahead and do that. So we have d times d, and then d times 3. Then we have negative d times d, and negative d times negative 4. Let's go ahead, let's simplify those expressions. Let's multiply. D times d, adding your exponents, will give you d squared. Remember, the coefficient's going to be 1 since you're multiplying those coefficients. 1 times 1 is 1. We have d times 3, which really can't do anything with, but let's use the commutative property to put our coefficient first. So that'll be 3d. Then we have d times d, which is, again, d squared, adding our exponents. We have negative d times negative 4. So negative 1 times negative 4 is going to give us a positive 4d. Bringing that right side down as we go, just so that we don't forget we did have an equation that we need to solve. We do have another side that we're going to need to deal with. Let's go ahead. Let's continue simplifying that left side as we go. I do see that I have like terms. So I have d squared minus d squared. If I take d squared minus d squared, I'm going to get 0d squared, which is 0 and will ultimately cancel out. I then have 3d and I have 4d. So those I can combine. 3d plus 4d will give me 7d. So we have 7d equals 9d minus 16. At that point, we're just going to solve a normal 2-step equation. We need to get our variables to the same side. So easiest way to do that would be subtracting 9d from both sides. So you have negative 2d equals negative 16. Then divide by our coefficient, negative 2, and we get a d value of positive 8. As with all equations, you certainly can check to make sure that this is correct. If you take this value for d and substitute it in every place up here in our original equation for d, you could verify that both sides are in fact equal. So that was multiplying a monomial times a polynomial. Let's take a look at how we multiply polynomials. So multiple terms times multiple terms. The first way that we're going to talk about is through a method called FOIL. Now, we're going to talk about kind of other ways to do this. This is just one way to remember how we can multiply 2 binomials. So FOIL, basically what that means. So F stands for first terms. So in a binomial, remember that we have 2 terms that are going to be multiplied. So basically what we're saying is we would multiply the first terms as the first part of our process. Then we have the outer terms, which if you think about that, it would be the terms on the outside. So here and here, multiply those. Then we would have the inside terms, which are going to be the ones that are closest to each other on the inside here. And then we'd have the last terms. So basically notice that's just looking at all different combinations, multiplying all possible combinations of each binomial to the other. Another way to think about this is basically what you're going to do is you're going to take the first term in your first binomial and you're going to distribute that through. Then you're going to take the second term in your first binomial and distribute that through. So let's take a look at what this looks like. This can get a little bit complicated, so just make sure that you're following along and make sure that you are kind of showing your work clearly so that somebody else can follow it, so you can follow it after you're done with your notes. So in this first binomial here, in example 1a, we're going to go ahead and we're going to multiply the first terms. So basically what we're going to do is we're going to distribute that first x through to the binomial, the second binomial. So we have x times x, and then we would multiply the outer terms, so x times 9. Notice basically all we're doing is we're taking this first x and we're just distributing that through to both of those terms in the second binomial. We'll then proceed with this -4. We're going to distribute that to the x, multiplying the inner terms, and then we'll take that, distribute that to the 9, which are our last terms. Again, basically all you're doing here is you're basically taking the second part of that first binomial and distributing that through. Let's go ahead and let's write this all out. Let's simplify it and let's see what we come up with. So remember, we multiplied the first term, so we had x times x. Then we had x times 9. Then we had -4 times x. And then -4 times 9. Always make sure that before you try and combine like terms, before you try and add or subtract anything, make sure that all of your expressions are simplified. Right now, these aren't. We can simplify them a little bit, make them look a little bit nicer, so then we can combine our like terms after we finish multiplying. So x times x would give us x squared. X times 9 we can rewrite as 9x. -4 times x is just -4x. And then -4 times 9 is -36. You will see that we have one pair of like terms here. We have 9x minus 4x. So we can simplify that. We'll have x squared plus 5x minus 36. We don't have any more like terms, nothing more we can combine. So this is going to be our final simplified answer. Let's take a look at another very similar example here in B. So again, you're going to use FOIL, or in other words, we're just going to distribute the first term and then distribute the second term of that first binomial. So 4x is going to get distributed to the 3x and to the 8. So we have 4x times 3x. And then we have 4x times -8. Then we'll distribute our next term in that first binomial. So we'll distribute the 7 through to the 3x and the -8. So we have 7 times 3x and then 7 times -8. And I think you can start to see that these can get a little bit complicated. It can get messy. So again, really important to keep your work very organized, very neat, so that not only can you follow it, but other people looking at your paper can follow it. All right, let's go ahead and let's finish multiplying these. So let's simplify. 4x times 3x would give us 12x squared. 4x times -8 would give us -32x. 7 times 3x gives us 21x. And then 7 times -8 gives us -56. Once again, you'll notice that we do have one set of like terms. So let's go ahead and combine those to simplify. First term stays the same, 12x squared. We have -32x plus 21x, which would give us -11x, and then -56. Again, no more like terms, so that is our final simplified answer. You notice that both of these end up as being trinomials in the answer. You may be wondering if that's always the case. It will not always be the case, but it often is. So many times with these problems, you will find like terms. So make sure that you're always looking for like terms after you distribute, after you multiply. All right, so let's get into the fun problem. So now we're going to multiply multiple terms times multiple terms. So in this first one, we have 2y plus 5, a binomial, times 3y squared minus 8y plus 7. So we can't really use FOIL here because FOIL really only uses 4 terms, which is why oftentimes I don't necessarily use that method, but I like to think about it more as distributing. So what we're going to do is we're going to take each term from this first binomial and distribute it through to the trinomial that it's being multiplied by. So I'm going to take 2y, I'm going to distribute that to each of those 3 terms in the second polynomial. So I'm going to rewrite, I'm just going to write down what we're multiplying here. We have 2y times 3y squared. We have 2y times -8y. And then we have 2y times 7. Okay, now I'm going to go ahead and I'm going to multiply my second term in that binomial. I'm going to distribute that 5 through to each of those terms in the second trinomial. So we have 5 times 3y squared plus 5 times negative 8y plus 5 times 7. In case I didn't tell you, very important to write your work neatly and organized. You'll also see that these problems can become very long. And again, as we get better with these rules, as you really start to have them memorized and are able to do them accurately, you're going to be able to skip some of these steps in between, and you'll be able to make these problems a little bit shorter and probably a little bit cleaner. So let's simplify each of these products. So we have 2y times 3y squared, which gives us 6y cubed. 2y times negative 8y gives us negative 16y squared. 2y times 7 gives us 14y. We then have 5 times 3y squared, which is 15y squared. 5 times negative 8y is negative 40y. And then 5 times 7 is 35. All right, let's take a look at our like terms. Looks like I only have one term that has a y cubed, so I'll go ahead and start with that, 6y cubed. Y squared, I do have two of them. So I have negative 16 plus 15y squared would give me negative 1y squared. I then have two terms that just have a y. So 14 minus 40y would give me negative 26y. And then lastly, we just have our constant, 35. That is our final simplified answer. All right, let's go ahead and finish it off with probably the most complex type of a problem that we're going to do. We probably will never do anything more than a trinomial times a trinomial in here. This is kind of the most that we will do. So with this, I'll warn you ahead of time, you're going to want to write kind of small for this, because if you notice in this previous problem, when we multiplied a binomial times a trinomial and we simplified, we ended up with 6 terms here. So we had 2 terms times 3 terms gave us 6 terms before we combined like terms. So here I have 3 terms and 3 terms, which means we're going to have a total of 9 terms before we simplify. All right, so again, write neatly, write small. So we're going to distribute, first of all, x squared to each of those 3 terms. So we have x squared times 3x squared times negative 7x, x squared times 2. Okay, we're a third of the way there. So now we're going to take the 4x. We're going to distribute the 4x 3. So we have 4x times 3x squared, 4x times negative 7x, 4x times 2. 2/3 of the way there. Lastly, we need to distribute this negative 5 through, which gets a little messy because I went above with the first, below with the second, really don't have anywhere to go with that third, but we're distributing that negative 5 through. So negative 5 times 3x squared, negative 5 times negative 7x, and negative 5 times 2. So once again, notice we have 1, 2, 3, 4, 5, 6, 7, 8, 9 terms that we now need to simplify. So let's go ahead. Let's start with the first one. So we have x squared times 3x squared, which is 3x to the 4th power. We have x squared times negative 7x, which is negative 7x cubed. X squared times 2 is 2x squared. 4x times 3x squared would be 12x cubed. 4x times negative 7x would be negative 28x squared. 4x times 2 is 8x. Negative 5 times 3x squared is negative 15x squared. Negative 5 times negative 7x is 35x. And then negative 5 times 2 is negative 10. All right, we are almost there. So we have distributed everything that we needed to. We multiplied all of those terms to get our 9 terms now. All we need to do is identify any like terms, combine them, and we'll be finished. So first we have 3x to the 4th. Don't have any like terms, so let's just write that down here as part of our final answer. We have negative 7x cubed which I do have another x cubed term right here. So I need to combine them. Negative 7 plus 12 gives me 5x cubed. We then have x squared, and x squared. So notice that we actually have 3 terms here that have x squareds. Need to combine them all together. So we have 2 minus 28 minus 15. So 2 minus 28 would give us negative 26. Minus 15 would give us negative 41x squared. And then we have x terms. So we have 8x and 35x. Combine those to get 43x. And then lastly, we just have our minus 10. That is our final simplified answer. I told you it'd be fun. All right, folks, now it's time to practice. As you can see with this type of problem, there are a lot of different places that you can make mistakes, especially if you're not super solid with your multiplying monomial skills. So time to practice. Please let me know if you have any questions. Thanks for watching. Have a great day.